Okay, so let us talk. When you're having differential equations, technically the thing that you should notice is that differential equations are technically you have to be like strategic when you come to this thing. You have to be strategic when you come to solving differential equations. For example, if I give you this differential equation, I haven't taught you any technique to solving this differential equation. What do you think is the technique that you can use to solve this differential equation? Now notice that you have y double prime and you have y prime. So that's 5. So there's some function y that exists that if you take its second derivative, if you take its first derivative, you get something like blah blah blah. And then if you get the second derivative equals blah blah blah. And then if you have y double prime, you can express this as y prime plus 5. So that technically means that the second derivative, the first, well, technically you can express this either way around. So that means that the first derivative is technically equal to the second derivative minus 5. So since I haven't taught you any technique, what do you think we can do here? Just think. The idea of maths is that you have to be strategic. Sometimes try to solve problems that you haven't been taught how to and see if you can tackle it. It doesn't matter even if you don't reach the final answer, as long as you know what to do, what's the skill that you can technically apply there. I know we have rules on how to solve differential equations, but then what do you think we can do here? Notice that you have y double prime and y prime. We know that the derivative of this one is this one, and we don't have any other variable that tends to prevent us from doing that. We don't have y. We just have y double prime and y prime. Then what we can technically do is let u equals y prime. And then we know that u prime is equals to y double prime. And then you can convert this equation. You can convert this equation into y double prime is just u prime. Then you have u prime equals y prime. We let that be u. See what I did here? Now we have solved this one. And then from here, let's suppose that y is a function of x. That means that du dx is technically going to be u plus 5. Then it's separable. It's separable. You see that it's separable. And then that means that you have du over u plus 5 is equals to dx. And then from then we can just technically find du over u plus 5. This is equals to dx. And then from then we just integrate from there. Integral of u plus 5. Integral du over u plus 5. That's just going to be in the absolute value of u plus 5. This is just going to be equals to x plus some constant c. And then we can solve for u, and then you're just gonna have u equals u will be equals to c by e to the x minus 5 if we solve for u in that case. What's u? U is technically y prime, so that means that y prime is technically gonna be c e to the x minus 5. So that means that dy dx dy dx equals c e to the x minus 5. And then from then we can just say dy equals c e to the x minus 5 dx. Okay, sorry, dx. And then from then you can just apply. Okay, sorry, let's do that on the next line. Then if you have integral dy, it's just gonna be integral c e to the x minus 5 dx. And then from then the integral dy, it's y. The integral of this one remains the same. It's just gonna be c e to the x, and then the integral of this one is just gonna be minus 5x, and then you just add some constant. Since you already have c here, you can add some constant d. Notice that I technically solved this differential equation without any new technique. So that's the thing. You have to be strategic when you come to these things. So even if they didn't teach you the technique on how to solve this one, then you can technically see, just analyze the equation. Just look at the equation and try to see if like there's something you can apply there. And then from then, when you come to math, you technically need to be strategic. So yeah, and that's it for this video. I'm just technically showing you that some things they don't need you to know a lot. And And then there are some other things that like you generally have to know then. So for example, we know that if y follows an exponential function, if y equals some exponential function, let's say c e to the x, or maybe let's say f of x, we know that y prime is just technically going to be f prime of x y. So whenever you see a y prime related to some function of x multiplied by y, you technically know that that's going to be an exponential function, stuff like that. So you can just technically play around with these equations. So in the next follow-up videos, then I'm just going to discuss the techniques of solving these ones. You can also have like triple prime. It doesn't really matter what you have. Let's say y triple prime equals y double prime plus x. How do you solve this differential equation? You don't technically need any skill. You can just substitute. I mean, there's nothing stopping you from letting u equals y double prime in this case. Then if u equals y prime, y double prime, then u prime is just equals to y triple prime. And then you have u prime equals u plus x. And then from then you can just solve this differential equation. You can see it's a linear differential equation. Then from then you can use the integration factor. And this is technically what I'm going to do in this case. In the next videos, then I'm just going to show you the techniques of this. The techniques that you can apply to solve differential equations. From here, I was just technically showing you how to be strategic with these things. Thanks for watching.